Welcome to the session on object-oriented programming and Java. In this session, we will look at a hands-on approach to explain object-oriented programming. We will look at the difference between C and Java and how they are different. So first, let's get started with what is a procedural and what is a object-oriented language. In this section, as you know, right, there are two different approaches to approach any problem. So procedural language is the traditional one which is done in C, and object-oriented is done in Java, C++, Python and other languages. So let's look at these two. What is a procedural programming? Procedural programming has a lot of functions. These functions take arguments, and these arguments which are passed to the functions, they perform operations with that and return back the value. You would have seen this in C programming, right? There is a main function, main calls different functions, and those functions perform specific operations. The problem is, in a very short time there are multiple functions calling each other and it is very difficult to follow the code, and that kind of a code is called a spaghetti code. So this kind of code is very difficult to manage in the long run. That's where object-oriented programming comes into play. In our object-oriented programming, you have something called state and methods. Overall, these are bundled together in a class. So the state or the property is a variable, typical class variable, and the method is something which operates on that particular state to change the value. So these are completely manageable because they reflect a real life entity. Let's take a TV as an example. So all of you know TV is a real life entity. Now to set a TV and then program a TV, you will have to understand the different states or what are all the different properties of a particular TV. Let's take, for example, the power. The power can be in on state or the off state. These are two different states for the power. Similarly, the volume can be a particular value, say 55, and the channel can be some number, right, say 845. When you look at it, this is the state of a TV at a particular point of time. Now, these states, right, define how a TV is at one particular instance. Now these can be modified. Now whatever defines the state is called the state or property. These are typically variables that you have. Now you can operate on these states using something called method. For example, you can turn the power on, you can turn the power off, you can change the channel. Using these operations, you can act on a particular state and modify the value. So methods help alter the state, or methods help modify a particular state. So methods are typically your C functions. Now when you look at a procedural way, you have a problem. How you look at the problem is you take this problem and you modify, you identify the different tasks that need to be done. So you look at what are all the functions that need to be there. And then you look at each function individually, you solve that function, which function calls which function, you first define that. And after the bigger problem is divided into smaller functions, you call each other and then finally you arrive and integrate at the end result. So this is how in a C program it is done. This is called the procedural way of programming. Now let's look at an object-oriented way. In an object-oriented way, first is to look at the different objects which are there in real world in that particular problem. So first is to identify the different objects. And next is to identify how these objects interact with each other. What are the states of these objects? What are the methods of these objects, right? First identify that. And once how each object interacts with each other is done, that's when your design is ready and you're ready to do the programming. So in object-oriented programming, the design takes up a considerable amount of time so that you identify how this problem has to be approached, and you build the classes and objects and how they interact with each other. Once all this is done, then each objects get individually developed and you build the overall solution. So this is the object-oriented way. Traditionally, if you look at it, slightly similar to the procedural way, but the major difference is first you identify the objects, the real world objects, what are their properties and functions, and then tie them back together to form the overall solution. Now let's look at a hands-on approach, right? We will get into procedural language, we'll get into object-oriented language, and we look at how actually in a procedural language it is done and compare it with an object-oriented language in hands-on mode. So in a procedural language like C, let's get into online GDB and then we will see how that particular program is done. So we are taking the program that we looked at earlier, right? The TV program itself. So a TV, we saw that it can be in various states. So this is represented in C using a struct. So a struct defines a object, right? In C, the loosely term, you can equate it to a class. So struct has, if you look at it, the TV has three major fields. One is the power, one is the volume, one is the channel. And if you look at it, we are having three types of TVs. One is Samsung, Toshiba and Apple. So I've defined three variables of the type struct TV. Now the problem that we are trying to do here is we want to perform some operations with that particular TV. Now what are the operations we are going to perform with that TV is we will get a choice from the user and we will invoke a method on a particular TV. For example, if he presses 1, I'm going to turn on the TV. If he presses 2, I'm going to turn off the TV. If he presses 3, I'm going to increase the volume. Pressing 4 decreases the volume. So there are 6 different options that you see. And after that option is chosen, I'm going to ask the user, which is the TV you're going to perform this operation with? Is it going to be on the Samsung TV? Is it going to be the Toshiba or Apple? Based on those two options, we get the user input and then we take an action. Right, so if he presses choice as 1, then I'll do a turn power on using the TV that he has chosen, right? So choice 1 is the operation, right? So that is turn power on, and the TV choice that he is making is Samsung, Toshiba or Apple. He has 1, 2, 3 as options through which he can pass the TV. Now in a turn power on function, initially he has chosen the operation as turn power on. And for that, I have to pass which is the TV. For that particular function, I have to pass which is the TV he has chosen for which the operation has to be performed. So in C, if you look at it, they are loosely coupled. They are not tied to each other, right? I have to pass to the turn or power on function, which is the TV. And within the function as well, right? When they receive, here in the function, they receive the TV choice. And then here again I have to check up, oh, if it is choice 1, it is for Samsung, I need to change the power. Choice 2, Toshiba, I have to change the power. Similarly, power off, the TV that he has chosen, oh, he has chosen the Samsung TV. For that, the power state has to be turned to 0. So even within the function, it is not tied. I have to inform within the function which is the TV he has invoked, right? This is the problem in C programming. So when you compare it with the Java program that we will show after this, you will clearly understand the advantage of a Java program over a C program. So in C, if you look at it, they are not tied with each other. I had to get a choice from the user on the operation he or she is going to perform, and I had to get a choice of the TV that he or she is going to choose, and then pass both to that particular function, and there we made the change. Let's look at the same program in Java. You'll see the advantage. So here is a ready-made program that I've already made for the Java. Again, same, right? The class is the equivalent of a structure. In a class, you can have the methods as well. In C program, you cannot have the functions, right? Within a particular structure. But in Java, you have the variables power, state, volume and channel. Very similar to how you had in C structure. Here you have the methods within the class itself. So you have a turn power on, turn power off within that particular class. So they are all tied together, right? The variables, which we called as state or property in Java, and the methods, which is equivalent to the functions in C. Here you are tying all these together. And within that particular turn power on, you are saying the power state is 1 or power state is 0, right? This is the on or off for that particular TV. Now, whenever, right, this is set, these are all tied together for one TV. The object and method are tied together here. Now, when you have to operate on this particular object, right, on this particular TV that you see here, you will see how it is seamlessly done. You don't have to pass the function. Here, if you see even to the turn power on, I'm not passing. So here when you create an object, so that's the template, class is the template. In the next section, you will discuss about class and object in detail. But for now, right, for that particular TV, I am creating an object. So TV Samsung equal to new of TV will invoke an object. It will instantiate an object of this class. You will study that concept later. For now, bear with me for the syntax. So we have a Samsung TV, we have an Apple TV, we have a Toshiba TV. All these three TVs are created. And now I am getting the user choice. And let's assume the user says, I want to turn on the Samsung TV, right? All you have to do is Samsung.turn on. So you're not saying turn on with the TV choice. You see the difference? You're not doing that. You're not calling the turn on function. You're just saying Samsung and you're invoking the turn power on function, and automatically that particular function gets invoked. That's the biggest advantage in Java. So they are tied together. When you call Samsung.poweron, this power on function for Samsung TV gets called. Here if you see, we are not passing the TV for choice at all. Automatically that gets invoked, and any changes you make will happen. Say if you change the volume in that particular function, Samsung's volume will get changed. If you make a change to the Toshiba TV, Toshiba's volume will get changed. So this is the biggest difference between a procedural language and an object-oriented language. Here the state and the methods are tied to a particular object. In a procedural, they are very loosely coupled. Within the program, you have to make all those distinctions and changes. So now this is a logical segue for us to discuss the class versus object that we talked about, right? So in the earlier section, I loosely used the word class and object interchangeably, right, when I discussed that particular part. But now we'll dive deep and we'll understand what is a class, what is an object, what is the difference between them, and how they are tied in a Java language. So the textbook definition of a class is: class contains the states or the property that we talked about, and the methods. Method is nothing but the function. It is also called as the behavior. So class is a template or a blueprint. So it will not allocate any memory for a class. It is just a structure. And now the object is the real instance of a class, right? Object is where the memory gets allocated in this. Still, if you look at it, this looks like a textbook definition. It is not clear as to how this is going to work. So let's look at this in action now, right? So what is a class, what is a method, and how do they work together? Let's look at that in action. We will take a real example and then we'll discuss this. This is a blueprint or a plan for a particular house. So in this house, if you see, there is a 3-bedroom house. You see hall, kitchen, everything. This is what gets built first. This is just a template. So based on this template, we are going to construct houses. So this template is first put together to say how that house has to be built. How does it look like? Once this is done, once this is finalized, then you will build a real house based on this. That real house is the object. That blueprint that we define is the class. So if you look at the real object, for the real object, you need to have memory and others. And any amount of houses can be built based on the same plan, right? That's the biggest advantage. A class can have multiple objects. Here there is a 3 model of an apartment, and you can construct any number of apartments, right? You can construct 10 floors, 20 floors, 30 floors based on this. So the plan is the blueprint or the class, and the object is any number of objects can be created based on the template. Each object consumes its own memory. It is a real life entity. Object is a real life entity. The class is just a blueprint, white paper, or a model that we have created based on which these objects are created. Hopefully this section, right, explains to you clarity between what is a class, what is an object. Class is a template or a blueprint, and object is the real life entity which has the same, whatever you define, that same thing gets really into life is the class object. So now let's look at this class that we discussed earlier, right? We had a class. We said this is just a template that you see here. It talks about all the states which are there, which is basically the power, volume, and channel are the states that we have. And then you see the methods here as well, which are the methods which are part of the class. So turn power on, turn power off are the different methods. Now for this, there is absolutely no memory that is allocated. This is just a simple class. Now whenever I have to create an object based on this, that's where the memory gets allocated. So when I say Samsung equal to new of TV, of the TV type, of the class type, it allocates memory and creates a Samsung object. Similarly, when I call new of TV, it allocates Apple and then Toshiba. So 3 different objects are created. 3 different memory segments are there. Each has its own. Apple has its own power state, volume, and channel. Samsung has its own power state, volume, and channel. And Toshiba has its own power state, volume, and channel. This is what is an object. So we created one class which is of type TV, and based on that we have created 3 different objects, one for Samsung, one for Toshiba, one for Apple. So this is how an object and class operates in a real world in a Java program. So next section is on constructors. So the text definition of constructor is different. In this section, we'll go into the details of how constructor works and what is a constructor, right? So let's first start with constructors. Textbook definition is it's a method and it is invoked whenever an object is initialized or created, right? That's when a constructor is created, and the constructor is used to initialize an object with some default values. So this is what a constructor has been given in the textbook. And the constructor name is same as the class name. The constructor does not have a return type. These are other properties of a constructor. So now what we will do in this section is we will talk about details of how the constructor works, right? So we will use it to initialize an object. We will get hands-on. We'll get into a real, that same TV program we will take. We will look at how the constructor is created for that and how it is used to initialize an object. Whenever there is a talk about a constructor, always understand that constructor is used to initialize an object with default values. That's what is very important to understand about a constructor. So now the same program, if you see, we have a class TV and it has three states: power, volume and channel, and you have two methods: turn power on and turn power off. Now as I said, right, whenever you create a particular class, it will have its states and it will have its methods. Now these states and methods, we don't know what the initial values are going to be, correct? So what we will do in this section is I am going to actually have something called as a name here. So this name is going to give me the name of the TV. Say if I want to display, right, I want to display a Samsung TV, Toshiba TV, Apple TV. I just want to display, so I've created a name. So when I say TV Samsung equal to new of TV, we already saw that the new keyword helps in allocating memory. Whenever you see the new keyword, it allocates memory, and the TV, open bracket, close bracket, you see it calls the constructor. Now we don't see any constructor here. Let's create a constructor. As we saw earlier, constructor name is the same name as the class name. So TV is the class name. So the constructor name is also TV. And constructor does not have a return type, so you don't see anything there. So here we'll set with some default values. So I'm saying name is not initialized, right? So I'll have that as the name. I'll say power state is the second variable that we have. So I'll say power state is 0, right? So this is the default value. So 0 means off and 1 means on. Third is we have the volume. Again, I'll say volume default value when the TV start, it has to be 30. And channel, I'll set a channel number initial value as 300. Now this is what is called as the default constructor. That is, there are no parameters passed and we are just calling a constructor. Second, what we need is, now this constructor, right, will get called whenever a new of TV, right, Samsung is equal to new of TV is called. This constructor automatically gets called and all the default states of variables are clearly set. That's why it's called a constructor. It helps in setting up the default values for that particular variable. The Apple TV that we saw, it sets the default value for that. Samsung again gets initialized to none, and the third one that we saw, Toshiba, also gets set to none. Actually, there are three types of constructor. What we saw so far is called as the default constructor or non-parameterized constructor. Second is a parameterized constructor. Third is a copy constructor. Now we are going to look into the details of each of these constructor types. So default constructor is something we already saw. Parameterized we'll see in detail, and copy constructor we'll see in detail. So as I saw earlier, right, when you say TV Samsung is equal to new of TV, the default constructor gets called. That is, it sets it to the default values, right? We saw that already. This is called as the default constructor and we have it here. This is the TV. This is the default constructor. Now we have set some default values for the different, so for the state variables we have the default values. Now let's do the parameterized constructor. So if you look at it, we have a name, we have a power state, a volume and channel. So I'll declare this name, power state, volume and channel. I'm going to have 4 different variables. So I'll say string s, int p, volume and channel, right? So and then I'm going to initialize with that name. So when it says, when they pass a name, I'm going to set that name to that particular name. And power state, I'm going to pass the P, and volume, I'm going to pass the V, and channel, I'm going to set the value as C. So whatever values they are passing in that main program from the main program, they get set to that particular object. So these are called parameterized constructors. This is the parameterized constructor and we need to invoke that, right? So for the Apple TV, what I'll do is I'll make it as a parameterized constructor. So I'll use the name as Apple. I'll set the volume power state as 0 so that initially it is off. I'll set a channel number as well. So volume as 10 and channel number the fourth value that we had, right, the state. So channel number is 100. So these are off state, channel is 10 and volume is 10 and channel number is 100. This is the initial value and the parameterized constructor gets called with these values. So we saw the default constructor, we have seen the parameterized constructor. So these gets invoked, understand, automatically these get invoked whenever that particular object is created. So to see it in action, I'll also create a display method. So system.out.println, I'll have the name, I'll print the name of which TV it is, and I'll print the power state of the TV, and I'll print the volume. These are the state variables that are there, and I'll print the channel. These are the four I'm printing here. So yes, I printed the channel. So now from the main, right, from the main program, if I call Samsung.poweron, I've turned the power on for the Samsung. So initially after the default values, first what we'll do is after the default values, we'll do a display. So Samsung, if you see, we did a default constructor. So it will go with the default values. And Apple display, I'm going to use the Apple values, right? Whatever we set as Apple 0, 10, 100 should come. So if you look at it, yes, for the Samsung it is showing it is not initialized, power is 0, volume is 30, channel is 300 because we called the default constructor. Remember that we did not set the value of Samsung to Samsung, right? That's why it is invoking the default constructor and it printed those values from the default constructor. That's why you see the name as not initialized, power as 0, volume as 30 and channel as 300. And for the second Apple TV, we had set it as 0, Apple 0, 10, 100. That's why when you saw the display, you see the value of Apple, power is 0, volume is 10 and channel is 100. So the first one is called as the default constructor. Second for Apple, we did the parameterized constructor. So these are the two major constructors that we have seen, right? So a constructor again is used to initialize an object with default values. And here we have initialized using the default constructor as well as the parameterized constructor to initialize the two objects for the two TVs that we have seen. Now let's look at the third type that we have, right, which we talked about as the copy constructor. We will look at that part next. So in a copy constructor, what we do is, so let's assume we already have a TV with a default constructor. We have another TV. We have another constructor with which is a parameterized constructor. Third is the copy constructor. For a copy constructor, you will pass another object which is already initialized. So we are passing the parameter of a reference of another TV, right? So the TV A is the reference. So when it is passed, we'll copy the values from that object which has been passed, right? The reference, from that reference, we will copy the values from that particular object which is passed and set it as the default value for the new TV that we are creating. So this is called as the copy constructor. Basically, we are copying another object and initializing this particular object. That's why it is called as the copy constructor. So TV A is the reference of an object which is already existing. So this is the copy constructor. We have seen that. Now we have to really create, right? So we will initialize an object and then we will show you how to get it done. Let's see that next. So in the main program, we'll have to, so we have a Toshiba TV. I'm saying TV of Apple. So if you see, Apple is the reference of the Apple TV, right? So I'm passing that as that reference of Apple TV to the Toshiba TV's constructor. So when you do this, what happens is automatically the values of Toshiba TV will be initialized with whatever is there in the Apple TV. So let's do a display and see what happens here. So Samsung is default, Apple is displayed, and then Toshiba should have the same values as Apple. That's what you see here. The second and third rows are the same. There is no difference between the second row and third row. Primarily that's happening because it is a copy constructor. So all the values of Apple TV have got copied over to the Toshiba TV. So this is called copy constructor. Now if you want to change the value after the constructor is called and then the values are changed, you can change one or two values if you want. So I want to change the name of Toshiba TV as Toshiba. All the other values I am fine with whatever is there. Let's assume the name alone I want it as Toshiba TV. So I am saying the reference of Toshiba, in that there is a name field. So for that particular name field, I am going to set it as Toshiba, right? And Samsung, Samsung was default value, right? So instead of not initialize, let's set it up as Samsung, so that the value comes up when you display that, right? So now we have set Toshiba.name as Toshiba, Samsung.name as Samsung. So after this we have the two display functions, Samsung, Apple, Toshiba, all the three are displayed. Let's now print it. Now you will clearly see the names. So it says Samsung, power is 0, volume is 30, channel is 300. Apple's name is there, power is 0, volume is 10, channel is 100. Toshiba, if you see, given that we changed the name to Toshiba for the third one, Toshiba is displayed, but remaining values are copied over from Apple. So you see the power as 0, volume as 10 and channel as 100. So Toshiba TV's name that we set now has overwritten the Apple name that we saw earlier, right? So this is the advantage of constructors. So let's summarize it a bit, right? Constructor is a method. Constructor is used to initialize an object with default values, right? So this is a constructor. Whenever a constructor is called, it is used to initialize an object. Important word is initialize. Constructor's name is same as the class name. Constructor method does not have a return type. These are the properties of a constructor. Three types of constructors are there: default constructor, parameterized constructor, and copy constructor. And all these three constructors we saw in action now in our program. So now let's jump in to find out what is a this keyword. This is, so far we have not used it. In this particular program, we are going to use the this keyword. So earlier you saw that the parameterized constructor when we had, right? In that parameterized constructor, I had string S, int P, volume V, and int C, right? Let's assume that instead of string S, I'll have it as name, power, state, volume, and channel, right? So these are the same names as the class name, which is also used in the parameter names. If you do that, then if you initialize name is equal to name, power state equal to power state, volume equal to volume, and channel equal to channel, it will have a confusion, right? Because the same name is used. Name equal to name means it will not understand, hey, what should I take and what should I initialize, right? So there will be a huge confusion if I said power state equal to power state, if I say volume equal to volume, if I say channel equal to channel, right? Which volume should I take? Is it the parameters volume I have to update, or the class state variable's name is exactly same as the parameters name which has been passed to the function? So there is a huge confusion for the program. So if you run this, it will definitely not work, because there will be a confusion for the Java. What do you mean by name equal to name? What do you mean by power state equal to power state? What do you mean by volume equal to volume, right? So then class name or the state variable's name is same as the parameter's name. That's when you use the this keyword. When you use the this keyword, what happens is Java automatically understands that this represents this particular object that we are operating with. So it takes that as the state variable name that we have. So it takes the name of the object, that particular object's state variable, and it initializes that with the parameter which has been passed. So this dot name equal to name means the object's state variable name is initialized with the value of name which is passed. So when you run this, this will work fine. There is no problem. But what is the use of this, right? Now we understood this, but really speaking, is this the real crux of this? Why do we really need something like this? I can use some other parameter name, right? That's what you would think. But when we have multiple users, some person would be developing it, some person will be using it. So it's always, there needs to be a way out. That's why the this keyword is used. This has multiple purposes apart from what we have seen here, right? So one is, this keyword can be used to refer current class instant variable. That's what we use now. There are multiple other uses of this keyword. We will not actually discuss it now. We will discuss each of these later, right? So we will just wait for a moment. We will discuss that. Next, let's look at reference. So I use the word reference multiple times, right? So when I see TV Samsung is equal to new of TV, right? You see that statement, TV Apple is equal to new of TV. So these Samsung and Apple that you see here, both these are called references. So when you say Apple TV Apple equal to new of Apple, this is what happens here in memory. So there is a memory allocated in the heap memory in the RAM, and there are, for all the state variables, individual memory is allocated, and you see that the name, power state, volume, channel, there are 4 variables that we allocated. For each of those variables, separate memory is allocated, and that memory is referenced by Apple. This is slightly different from how it works in C. You will understand this shortly. For now, that memory is referenced by a variable called Apple. So now this reference, let's see how it is used, right? So you have a reference. Now let's say I say Toshiba equal to Apple. So what happens is, it's not like there is going to be a new memory created for new heap memory to store all the Toshiba variables. No, that's not what happens. Toshiba will point to the same memory that Apple was pointing. Let's see this in a pictorial format, right? This is Toshiba. Both point to the same memory. So these are called references again, even though I'm using the word pointers like C. These are called references in Java. Both Apple and Toshiba point to the same memory, same object which is there in the memory. So they are not different. So when you change using Apple or when you change using Toshiba, the same value gets modified, right? So it's hard to believe how it works. Let's see that in action now. So I have said Toshiba dot let me change the this one, right? Display. So I'll call the display of Toshiba first, so that we'll see what is the current value, what is the current thing that is there. If you see, both Toshiba and Apple to the point to the same memory. So when I display Toshiba, you will see that Apple power 0, volume 10, channel 100, right? That is the parameterized constructor that we had called to initialize Apple. You see that the same values again repeating for Toshiba as well, because Toshiba and Apple are pointing to the same memory. Now if I say Samsung is equal to Apple, right? So what happens to the Samsung? Samsung we created a separate memory, and then Apple we created a separate memory. But when you say Samsung equal to Apple, the memory that Samsung was pointed to initially, right? That memory is just like that there. No one uses that. Starts pointing to the same memory that Apple is pointing. If you do this, all three, right? So once we do this, Samsung, the memory that Samsung was pointed to is no more there. Samsung now references to a new memory that Apple and Toshiba are already pointing to. So that all three now reference to the same memory, and the memory which Samsung was initially pointed to gets freed up. So garbage collector is there in Java, which cleans up memory which no reference is pointing to. Coming back to the code now, let's look at it. So we had Samsung is equal to Apple, right? So all three are now pointing to the same place. So if I do a display, we initially set it as Apple. So even when you display it with Samsung, it will still print as Apple. Let's run it and see. You will see that it still prints it as Apple, power is 0, volume is 10, and channel is 100. So this proves that it is not copying. All three are referencing to the same memory location. If you want, you can display using Toshiba.name equal to Toshiba. That means the memory, in that particular memory, we are changing the name to Toshiba. If you display it with Apple, still it will print only the name as Toshiba, because all three are referencing to the same memory. That's what it means. So let's run this and then we'll see what happens. Ideally, we should see Toshiba 0, 10, 100 are the values for the particular object or memory. So let's see this. So as you can clearly see, it shows the Toshiba, power is 0, volume is 10, and channel is 100. So it proves that all three are pointing to the same memory. So let's quickly recap what we have seen here. So we see that Samsung is new of TV. A new memory was allocated with default constructor. Then for Apple, we used a parameterized constructor. So a new memory was allocated to that. And for Toshiba, we made it reference to the same memory of Apple. And after that, what we did is we made Samsung also point to Apple. So whatever was the initial memory allocated for Samsung gets freed up by garbage collector, and all three point to the same memory. And then we use the display function of Samsung. We see that the value of Apple gets displayed. We change the name using Toshiba, and then we try to display using Apple. You still see Toshiba. So just we did certain exercises to say that all three are pointing to the same memory. So this is how reference variable works in Java. So now next section, right, we'll get into the core concept of object-oriented programming.